Alright, working on number 15 here. 15 is kind of a doozy. It's a little tough. I want to show you something on this problem um, by looking at the graph of the function. So we've talked about graphing as a way to check our answer to see if graphically if this thing crosses or intersects in the same place for the same x value that we think it does. So what I've done is I've put the square root and what's on each side of the equal sign and different y values, because if we want to see when they equal each other, like we have in this function, when are these two things equal, then that would be where they intersect on our graph. So you see this red line and the blue line, they seem to almost or come close to intersecting right there. It's a little hard to tell. So something that you need to know when you hit second trace 5, it's going to say first curve. Okay, so first curve, it looks like it's on the blue line. I hit enter. And then second curve, now it's on the red line, and I hit enter. And then it says guess, and I hit enter. And it says error, no sign change. It cannot detect a place where these two things have intersected. So let's go to this. One other option. So something that happens when the intersection point is also the vertex point for one of these functions is it won't detect that intersection point. So if you go to the table and you look at when x equals 1, y1 is 3 and y2 is 3. So they have the same value when x equals 1, 3 and 3. And so it appears to be, when you do second trace 5, enter, 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 it looks like there is no solution because it says there's no sign change. But if you look, those actually do intersect right at when x equals 1, y equals 3. So let's go into this problem knowing that b is equal to 1. Here is our solution. Other solutions, since they only intersect in one place, other solutions are going to be extraneous. So let's enter this problem knowing that since we have square roots on both sides, we can square both sides. And that will get rid of this square root. We'll be left with 10b minus 1. And that is equal to, how do we square this? Well, that would be 3 plus the square root of 1 minus b times 3 plus the square root of 1 minus b. If we multiply that out, we have 3 times 3, it's 9. 3 times the square root of 1 minus b. And then we also have to multiply this by 3 as well. So we have another one of those, plus 3, 1 minus b, square root of 1 minus b. And then the square root of 1 minus b times the square root of 1 minus b is just 1 minus b. Combine some like terms, we get 10 minus b plus 3 and 3 is 6 square roots of 1 minus b. So that's what we're going to put over here. 10 minus b plus 6 square root of 1 minus b. Now let's subtract 10 from both sides, and let's add b to both sides, and we will get 11b minus 11 is equal to 6 square root of negative 1, or square root of 1 minus b. Alright, at this point, if you want, you can divide by 6. Probably the safest thing to do here. And then we're ready to square both sides because now we have the square root by itself. So let's square this side. If we, when we square both sides, I would recommend squaring the numerator and the denominator separately. And I'll show you why here in just a second. We have 11b minus 11 squared is equal to, I'll get that denominator in just a second. Oh, we lost that square root. Good for us. It's just 1 minus b now. Okay, the denominator is 6 squared. That's 36. So what I'm going to do is I'm going to multiply both sides by 36 to get rid of that denominator right away. So I still have 11b minus 11 squared is equal to 1 times 36 is 36, and then negative b times 36 is negative 36b. Now that we're getting warmed up, let's multiply this out over here. So we have 11b squared. 11 times 11 is 121, and b times b is b squared. Alright, so when we multiply this out, just remember we have 11b minus 11 times 11b minus 11. So we're doing 11b times negative 11 right now. That would be negative 121b. And then a negative 11 times another 11b is another 121b. And then negative 11 times negative 11 is a positive 121. That equals 36 minus 36b. Let's combine some like terms. Minus 242b plus 121 equals 36 minus 36b. And now we still have we have a quadratic term, so let's get everything onto one side. That'll give us 121b squared. We need to add 36 to that. We'll get negative 206b. Not 20bb. 206b. Okay, so what I'm doing here is adding this 36b over here. And I'm going to subtract 36 from both sides. And that will leave me with plus 85 is equal to 0. You can use the quadratic formula to solve that. You can try your best to factor it, but let's just see if we can solve it by graphing instead. So 121b squared minus 206 plus 85. Let's clear these. So we've got 121x squared minus 206x plus 85. We're going to hit graph. See where our zeros are. Those will be our solutions. Looks like we have 2. So I'm going to go second trace. I want to know a 0. So I'm going to hit enter on one side of it, enter on the other side, and it tells me that that 0 is 1, 0. So x equals 1. And from the original graph we could see that 1 was our solution, and another solution would be extraneous. So we know that here we get b is equal to 1. And the other solution is extraneous because of what we had originally. B equals 1. Okay, so if you go back and you check it, you get the square root of 10 times 1 minus 1. It's the square root of 9. Is that equal to 3 plus the square root of 1 minus 1? Square root of 1 minus 1 is the square root of 0, which is 0. So is the square root of 9 3? Sure is. If you wanted to, if you hadn't checked it already, you could do second trace 0 and find that other one. Find out what it is. It is 0.70248, and you could try to plug that back in over here. So 70248. I'm going to store that to x. And then I'm going to do, so now my calculator thinks that x is that decimal. So 10x minus 1. Hit enter. 2.4 whatever. 3 plus, this is the other side of that square root function, or that square root equation. and I plug in that other value, and you see that I do not get the same answer. So those two are not equivalent, which means that the 0.70248 is an extraneous solution. And so all I have here is b equals 1. Let's keep trucking through this last problem. It's not near as bad as 15. So same situation here, except our square roots are on the same side. So let's change that. Let's add this square root to the other side. So now we have 2 plus the square root of 6 minus 2b is equal to the square root of 2b minus 2. So then we square both sides. Remember, we have to square that as an entire unit. So 2 times 2 is 4, plus 4 square roots of 6 minus 2b, plus 6 minus 2b is equal to, not the square root, of 2b minus 2. Because that square root and that square root canceled out. So let's combine some like terms. We have 10 minus 2b plus 4 square roots of 6 minus 2b equals 2b minus 2. Subtract 10 from both sides, add 2b to both sides, and you get 4 square root of 6 minus 2b equals 2b plus 2b, that's 4b's. And then negative 2 minus 10 is negative 12. We divide by 4 on both sides, which means we got to divide everything by 4. The square root of 6 minus 2b is equal to, well, 4 divided by 4 is 1, and 12 divided by 4 is 3. Now we're ready to square both sides again. And so we get 6 minus 2b is equal to b squared, because remember, b minus 3 times b minus 3, minus 6b plus 9. Now when we got it squared, we got a quadratic term, so we get everything to the other side. We got b squared. I started with negative 6b. I'm going to add 2b. That'll be minus 4b. I'm going to subtract 6 from both sides, and I get plus 3 is equal to nothing. Okay, now this one is much more beautiful because it factors. Factors of 3 that add up to negative 4, negative 3, and negative 1. So we get two answers, b equals 3 and b equals 1. Now let's go back and see if either of those, or either, is extraneous. B equals 3. 2 equals the square root of, 2 times 3 is 6, 6 minus 2 is 4, minus the square root of 6 minus 2 times 3, that's just 0, so that's 2 equals 2. So b does equal 3. That's a solution. Now let's check the other one. Does b equal 1? Well, that would mean 2 would have to equal the square root of 2 minus 2, that's 0, minus the square root of 6 minus 2. So 2 would have to equal negative the square root of 4. 2 would have to equal negative 2. And 2 does not equal negative 2, so b does not equal 1. It's an extraneous root, extraneous solution. Alright, so final answer on this one, b equals 3.